In this video, I'm going to show you how to simplify exponential expressions containing more than one variable. So let's look at this first example here. We want to simplify 3x squared y plus 5x squared y. And the thing to notice here is that these are both like terms. They both have the same variables, x and y, and each term has the same variable raised to the same power. So, for example, this first term has an x squared, and the second term also has an x squared. And the first term has a y just to the first power, and same with the second term here, y to the first power. We can always combine like terms, and we do that just by adding their coefficients. We can write this as the sum of the coefficients, 3 plus 5, and then both terms have that x squared y part in them. So we can just go ahead and add the coefficients. 3 plus 5 is 8, so just get 8x squared y. And there we go, that's how we simplify it. So this expression 8x squared y is, it really evaluates the same thing as the original expression. It's just a much simplified, more compact, concise way of writing it. Okay, next example, we want to simplify 3x squared y plus 5xy squared. So let's see if they are like terms. Well, both terms contain only the variables x and y, so that's looking good. Now let's check the power. So first term has x squared, whereas the second term just has x to the first power. So the powers aren't matching up. They don't match up on the y either. The first term has y to the first, second term has y squared. Okay, so that's an issue. That means these terms are not like terms. In order to combine the terms, we need them to be like terms, but since these are not like terms, then we just can't simplify further. It's already in simplest form. So there's nothing that we can do to simplify this further. It's just already as simple as it can go. Alright, here's an example which is a little bit more tricky. We want to simplify this bigger expression here, 3ab squared plus 5a squared b minus 2ab squared plus 4ab squared plus 3a squared b. Okay, so what we want to do here to start off is we want to underline all the like terms. And we notice that there are some ab squared terms and some a squared b terms. So let's just go ahead and underline all the ab squared terms in red. So we've got this 3ab squared. That's not an ab squared, that's an a squared b, so we just won't worry about that just yet. So ab squared, oh hey, that's an ab squared, and so is this one. That's an ab squared, and that's not an ab squared. Okay, so let's first write all of the ab squared terms together. So this is 3ab squared, and then minus 2ab squared, and then plus 4ab squared. Okay, and now let's worry about the other terms, the a squared b terms. So that's pretty clear. What are the a squared b terms now? It's just this one and that one, and let's write those together. So plus 5a squared b, and then plus 3a squared b. And now we can just look at all of the like terms here and all the like terms here, and separately we'll add the coefficients. So we'll add the coefficients of the ab squared terms. We'll put the coefficients in parentheses, 3 minus 2 plus 4, all times that common variable term, ab squared. And then in blue we'll have the a squared b coefficients added together. So plus parentheses 5 plus 3, and then the common variable terms, a squared b. Okay, so now we just need to simplify this. So 3 minus 2 is 1, and then 1 plus 4 would make 5. So let's write that down. 5ab squared, and then 5 plus 3, well, that's just 8. So 8a squared b, and there we go. Finally, we are done. That is the simplified form of that gigantor expression here. Much nicer, much more compact. Great. Here's another example. This one's even trickier because we've got three variables, x, y, and z. And we want to simplify this big expression, 2xyz squared minus 3xz squared plus 7xz squared plus 3xyz squared. So first of all, let's look for some common terms here. Let's look for terms with an xyz squared to begin with. So this is an xyz squared term, and then this term doesn't have a y, that's just xz squared, but we need a y in there. So we'll forget about that. This term also doesn't have a y, so forget about that. And then, okay, here's another xyz squared. Cool. Okay, so we've got those common terms. Let's just write them down together. So we've got 2xyz squared, and then bring that one over, so plus 3xyz squared. And now we can get the other terms here. The other terms are xz squared terms. So we've got a minus 3xz squared, and then a plus 7xz squared, and we'll write them here. So minus 3xz squared, and then plus 7xz squared. And now we'll go ahead and simplify this by adding coefficients of the like terms. xyz squared coefficients, we'll just add those. Those are 2 plus 3, and then pull out that common variable term, xyz squared. And then in blue here, the xz squared. So let's write that as plus, and then negative 3 is the first coefficient here, and then plus 7 is the next coefficient, and then put that common variable term xz squared, and we'll just go ahead and add those. So 2 plus 3, that is just 5, so 5xyz squared, and then negative 3 plus 7, that's a bit trickier to add, but that's really just 7 minus 3, which is just 4, so plus 4xz squared. And there we go. There we go. We've got it. This is a much simpler form than before, only 2 terms as opposed to 4 terms here, and we're done. So now we know how to simplify exponential expressions by combining like terms. And in the future, we'll also see another way to simplify exponential equations, which is called factoring.